Hello everyone. This video is in continuation with the previously discussed video Matter in Our Surroundings, an overview. If you haven't seen that video, then please do check that as well. If you like our videos, then please give a thumbs up and subscribe to our channel. In our previous video, we discussed an example where an incense stick, which after being lightened tends to spread in the room even more faster. We discussed how particles of the incense stick move rapidly when the temperature of the incense stick increases, as a result of which they spread faster. Well, do we know the phenomenon behind this activity? This phenomenon is called diffusion. Diffusion is the movement of any substance from higher concentration to the lower concentration. Let us understand this phenomenon with the help of a lightened incense stick. The incense stick placed at the corner of the room tends to spread its incense throughout the room. How does that happen? Well, the particles move from the area of higher concentration, which in this case is the incense stick, to the area of lower concentration, which is the entire room. As a result of the movement of particles, the smell of the incense stick spreads throughout the room and we are able to smell it. Let us consider another example. Consider adding drops of ink to a beaker containing water. As soon as we add drops of ink to the water, they diffuse into water, as a result of which we obtain a colored solution. Therefore, diffusion can also be termed as intermixing of two different substances. Here, in this case, drops of ink got mixed into the beaker containing water, as a result of which we obtain a colored solution. Particles of matter attract each other. This happens to be one of the most important characteristics which we shall be discussing here with the help of an activity. Let us consider an iron nail, a piece of chalk and a piece of wood. Now, we may wonder which of the following from each of this is easiest to break and which is the hardest. We shall observe that chalk amongst the three is easiest to break, as opposed to wood, which requires a little more force to be broken, and at last comes the nail, which is hardest to break. What can be concluded from these three? Minimum amount of force was required to break the chalk, a little more force was required to break a piece of wood, but the maximum amount of force was required to break a piece of nail. This suggests that the forces of attraction exist between particles. In this case, forces of attraction between particles of chalk were far more or less than the force of attraction between particles of wood and nail, as a result of which chalk was easiest to break. Then comes wood, in which forces of attraction between particles were more than chalk but still less than nail, as a result of which it required a little more force than a piece of chalk but still a lesser force than a piece of nail to be broken. And at last comes the nail, in which forces of attraction between particles are maximum and hence requires the maximum amount of force to be broken. From this activity, we can consider that force of attraction exists between particles. Here, in case force of attraction between particles of nail is maximum. Moving ahead in our topic, now we shall discuss the three states of matter: solid, liquid, and gas. This arises due to variation in characteristics of the particles of matter. Characteristics like we discussed, the forces of attraction which exist between particles, how closely they are packed, and etc. We shall be discussing all of these one by one throughout our course. Let us start off with the solid state. For a better understanding, let us consider an activity. Collect a pen, a book or a needle, and a piece of wood. Let us try to sketch all of these items in our notebooks. We will observe that these have definite shape, distinct boundaries and volumes. Well, now let us consider what happens if they are hammered or pulled or dropped? Solids maintain their shape when external forces are applied. Therefore, they may break, but it is very difficult for them to change the shape. One thing can be noticed here, that even after being hammered or pulled, solids tend to maintain their rigidity. That is, the forces of attraction between particles of the solid happens to be maximum as compared to the remaining two states, as a result of which they maintain their shape even when external forces are applied. Are these capable of diffusing into each other, or are they compressible? Let us consider an example. Whenever we try to press our book, does it compress? Or let us consider an example of a wooden log. What if we try to compress a wooden log with a full force applied? Does it compress? Well, no. Therefore, solids possess negligible compressibility. Now, few questions may arise in our minds. What about rubber band? Does it change its shape? Well, of course. A rubber band changes its shape. As soon as we tend to apply an external force to the rubber band changes its shape. But as soon as the force is taken away, the rubber band acquires its original shape. What about sugar and salt? Do they take the shape of jar in which they are kept? Well, of course not. They possess the same crystalline structure when kept in a jar or even on a plate. What about a sponge? It is a solid, but why are we able to compress it? We all know what a sponge is, and we are able to compress it very easily. But still, it is categorized among solids. So, what exactly happens here? A sponge has minute holes in it, in which the air is trapped. As soon as we apply force to compress the sponge, the air is expelled out of these air pores, as a result of which sponge undergoes a compression. Let us now consider the liquid state. We shall also discuss this with the help of an activity. Collect the following items: water, cooking oil, milk, juice, and cold drink. Also get containers of different shape. Put 50 ml mark on these containers using a measuring cylinder. Now let us consider the following questions. What will happen if these liquids are split on the floor? Does the volume remain changed? What about the shape? When we pour liquid from one container to another, does it flow easily? Well, let us discuss these questions one by one. As soon as these liquids are split on the floor, they start flowing. The volume of the liquids remain the same, but they take the shape of the container in which they are poured. When we pour liquid from one container to another, it flows easily. Liquids have a tendency to flow easily and take the shape of the container in which they are poured, as a result of which they are called fluids. Now, what could possibly be concluded from all these questions? In comparison to solids, we can say that the forces of attraction between particles in liquids is less than that in solids. In case of solids, the particles are tightly bound, as a result of which they are very rigid, and even after compression, they tend to not change their shape, as opposed to liquids in which particles are not that tightly bound, as a result of which they take the shape of the container and can easily flow. Also from this, we can conclude that spaces between the particles in solids are much less than that in liquids. That is, in case of solids, the particles are tightly bound, whereas in cases of liquids, there exist spaces between particles, as a result of which they are fluids. So, in our next lecture, we shall be discussing the gaseous state, and we will compare all the three states simultaneously to get a better overview. In today's video, we discussed the phenomenon of diffusion. We also discussed an activity in which we concluded that diffusion can also be termed as intermixing of two different substances. We discussed how particles of matter attract each other. by carrying out an activity, concluding force of attraction exists between particles. We briefly discussed solid and liquid state of matter and tried to draw a comparison between the two. In our next video lecture, we shall be discussing the gaseous state of matter. That's it for today's video. If you liked this video, then please give a thumbs up and subscribe to our channel. Thank you.